Okay, so I think I figured out an algebra problem. What I was doing is I was doing it the way we do it, because what matters when you're talking about these different circuit elements is really the ratio of V out over V in, and that's good enough to tell you about the behavior of these things. But we want to emphasize the change in resistance of these elements as a function of frequency. So that's why we wanted to come up with an expression for R2, which is the device under test. And so this is our STD plus RD. So we'll call them RS and RD. I'll leave that there. So anyway, so first thing to do would be V out times R1 plus R2 equals R2 times V in, and then we get V out R1 plus V out R2 equals V in R2. So V out R1 equals V in R2 minus V out R2. So then that equals R2 VI minus V out. So at the end of the day, R2 equals V out R1 divided by V in minus V out. Not hard. I made it way too hard earlier. I'm going to pause for a minute. We'll go to the circuit and reiterate how to take data. Alright, now I've set up a much cleaner circuit here, as you might notice. I used this breadboard small, and it has the rails we've used before. And you see I just hooked up the red and the black here. So the V in is pretty straightforward. It's always going into the standard resistor here, and I'm always measuring across. And of course, in this case, we believe what the function generator tells us the exact number. We can't always depend on that though. So in the real world, but so that's why we wire it up this way. And then I've got my 3 devices under test. In fact, we're going to actually also test the L and the C together at some point, but we're going to do that together next time. So now I'm ready to take the resistor measurement. And so again, you got to be careful about what it says here. See, it's 10 volts. This one says 20 volts. So with this having 10 volts on the right side, that means this is 1 volt per box. I'm going to pause this a moment. As I said, you should just go with a spreadsheet right away. So we've got V in is held constant, and it's 10 volts. And then we have our RSTD, which is 100 ohms. What else? Is that it? I think so. Right, but well, we have our RDUT. Of course we know it. There's no such thing as hidden values, unfortunately. And so we might as well write those there. We have our C, device under test, is 2e minus 6 farads. And we have our device under test, the inductor. And we said we're going to make it 10 times 10 to the minus 3 henries, so 10 millihenries. And then we wanted to, let's take a look. I need to look at the notes to get the frequencies we want to measure. And let's see, still, you can't see, I moved it off the slide here. Okay, so let's see, we have frequency tab V OUT. Now we got to be careful here. Oh yeah, so V OUT. Let's see, how do we do this? Oh, it's it's V resistor, because it's the voltage across the resistor is V out, and then we have the voltage across the capacitor and the voltage across the inductor. That wasn't hard. And then let's see, where's the formula? There it is. I'll copy and paste it into the spreadsheet here to make it easier to look at. Okay. And there we go. So then this is, give me a minute here, I'm gonna think this one through. I'm gonna pause this for a moment. Okay, one thing I forgot is now, because we're going to deal with alternating currents, instead of saying resistance, we say impedance. So that's with a Z, and we'll get into that when we meet again. And so let's see, so this should be Z. Okay, so this is going to equal to V out. Okay, so that's going to be whatever we measure here, and that's going to be times the standard resistor here, and we need the $, and then we're going to divide that by V in 10 minus the V out we measure. And so let's see. Yep. Now, oh yeah, so the V in has to have $. So let's put that there. It's always going to be the same V in. Okay, and what happens if we drag it there? Will it be correct? So that's the V out is, yep. So it's that, yep, minus, so it's going to be L6 twice. There it is. Okay, so dragging it across works. So we got those three, and then we need to type in our frequencies. Okay, so that's like, what did I put here? 50, tab 100, 500, and 1000, and 2000. And 3,000 and 10,000 and 20,000 and 30,000 and 100,000. Okay, yeah, probably could have had more of them. So now I know how many of these to drag down. Yep, they're all going to be 0 because we haven't entered anything in yet. And I can now put the borders. And okay, so we do have numbers. This is 7, and this is 10, and this is divide by 0, huh? This is 0.64. So what we'll do is let's just call it 9.99 so we don't get a 0 in the denominator there. Just means it's really, really large. Nice. So what happens is there's just not enough significant figures there. That's what it boils down to. Nice. And wait a minute. This is 0.64. Oh no, I got that right here. So we know these can all be 2 sig figs because that's the best we're going to be able to do. 2 decimal places. Yep. And then these are calculations. So we'll give them 3. Ooh, wrong way. Excuse me. Okay. So there's this table. And we can get this here. And let's see what border. So all borders. And so now we have to fill these in for each of those frequencies. And what we're going to do is we want to produce a graph that, let's see what happens. We want to do all these impedances. Oops, I thought right. So select that. Then I hold the control key down. And then we want to insert a scatter plot with dots and lines. And what? Oh, it understood what I wanted, huh? And so we got the frequencies down below here. And it looks like, yeah, we should add some more. Okay. So, up to 20,000. So, right. So let's see. There we go. I like that better. So you'll see this when I distribute it. Oh, what happens if I do this? Nice. Okay, great. So what's going to happen is we're going to do logarithmic plots, and you'll see it's going to look pretty. Okay, very good. Let's just zoom this in a little bit so you can get a look at it better. View, zoom to selection. Right, and there it is. See how all the 3 impedances there. There's our equation. Cool. All right, I'll get this published.